All right, this review is going to be done in the 3 different objectives. So I'm actually going to post 3 different videos just in case you don't need a certain one, then you don't have to fast forward. So we're going to start with the first objective on the first page where we will be expanding and condensing. So on the first problem, I'm asked to expand. So when I showed this to you in your notes, I told you, whatever you're asked to expand, write it out as multiplication and division, which means I have x times, and then x plus 4, and then divided by x to the 7th. And now what's going to happen is that multiplication and division is going to turn into addition and subtraction. So it's going to become x plus 4 minus x to the 7th. And now I am ready to put the logs back in for each of those different things. So this is the answer that should be going in the blank. So it will be log 7 with x plus log 7 with my parentheses, and then minus, and the 7 as the exponent is going to come in front as multiplication, log 7 of x. Now, that's a good answer. One thing you could have done on this problem, if you had wanted to, is these x's here could have simplified down into x to the 6th on the bottom. And then when I expand it as x plus 4 divided by x to the 6th, and then that division turns into subtraction, then in the blank, this is another way the answer could have looked. Log 7 of the parentheses minus 6, because the exponent moves in front as a multiplication, log 7 of x. So either of these 2 answers will work. The one in red is technically the better one, but that's okay. All right, number 2, again, I'm expanding. So the first thing I'm going to do is just ignoring the log, 3 times x to the negative 1st times y cubed, and I'm going to turn that into addition. And now each of these terms is going to get their own logs. So when I write my answer, I'm going to have log 4 of 3 plus negative 1, because that negative 1 moves in front as an exponent, log 4 of x, and then plus 3, again, the exponent moves in the front as multiplication, log 4 of y. All right, number 3, I'm condensing. So instead of having 3 logs, I'm going to condense it down into 1 log. So the first thing I'm going to do is take all of my multiplication and move it back as an exponent. And when I write this, I'm going to write this without the logs. So 16 to the 1/2, no log written with it, minus x cubed, no log, plus y to the 4th. And now the subtraction and addition turns into division and multiplication. So 16 to the 1/2 divided by x cubed times y to the 4th. Now the only thing when I write this as a fraction that's going to go in the denominator is this. Anything that's divided is in the denominator. That timesing y to the 4th will be in the numerator, not in the denominator. So I'll have 16 to the 1/2 divided by x cubed, and the y to the 4th goes in the top. If you leave your answer like this, that's fine. Some of you might realize that 16 to the 1/2 is like the square root of 16, so I'll put a 4. And this is technically the better answer. And so this is the one that I'm going to attach a log to it. So for my final answer, I should have a log with a base of 5, 4y to the 4th power over x cubed. All right, and the last one in this column, I'm expanding. So the first thing I'm going to do is deal with the square root, which is just the same as x over y to the 1/2 power. And now this means 5 times x to the 1/2 divided by y to the 1/2 because that 1/2 distributes in here because it's division. You can distribute the exponent in when it's all multiplication or division. And now the multiplication and division will turn into addition and subtraction. And now I'm just going to put the log back with all of those. So log 5 of 5 plus the half moves in front as multiplication, log 5 of x, and then minus 1/2 log 5 of y. And so in parentheses, just to kind of separate it out for my work, that's your answer. Now, another thing that some of you might notice is when the base of your log and what you're taking the log of are the same number, you can actually, that's worth 1. So if you see that and you want to turn this into 1 instead, you can do that. But you can leave it as log base 5 of 5, or you can turn that term into 1. That's up to you. All right, let's take a look at number 5. So number 5, although it's pretty simple, a lot of people miss it because when they ignore the logs and they look at 11 plus 50, their normal reaction is just to add them and make it 61. But remember, that addition is to turn into multiplication. So you should multiply them, which gives you 550. And then that log that we've ignored can move back with it. Number 6, again, we're expanding. So first I'm going to write this as, ignoring the log, 4 times x times y to the 4th divided by z to the 5th. And then that multiplication turns into addition. And that division turns into subtraction. And now, whoops, I bet I put it as division. Now each of those terms is going to get their own log. So here's the start of my answer. Log a of 4 plus log a of x plus the 4, remember, moves as an exponent, log a of y, and then minus 5 and log a of z. All right, remember, all your exponents move back in front as multiplication. All right, almost done with the side. On number 7, I'm going to condense. So the first thing is I'm going to move anything that's multiplied. Whoops, not the 2. Anything that's multiplied into the front as an exponent. So the 7 moves, the 5 moves, and the 3 moves. And when I do this, I'm going to rewrite it, but I won't put the logs. So it's going to be 2 to the 7th plus x to the 5th plus y to the 3rd. That addition turns into multiplication. And when I do this, I'm going to go ahead and take 2 to the 7th power, which is 128. And now I'm just going to write it without all those multiplication symbols. And that log that I've ignored, I'm going to bring back. So there's your answers for 7. All right, number 8, and then we'll move to the back. I'm condensing. So again, anything that's multiplied, the 1/5, the 2, the 1/2 will go back as an exponent. So I'm going to start with the 1/2. So 32 to the 1/2, and I'm not putting the logs with it, minus x squared plus y to the 1/2. The subtraction turns into division. The addition turns into multiplication. And again, the only thing that goes in the denominator is what's divided, just the x squared. So I'm going to go ahead and deal with this. Whoops, and I just realized that 32 should be to a 1/5 power. I wrote 1/2. So 32 to the 1/5, that's actually like the 5th root of 32, which is worth 2. So I'm going to go ahead and turn that into 2. Divided by x squared, the only thing that's in the denominator, and then y to the 1/2. If you want, you could write it as the square root of y. That's up to you. But now what I'm going to do is bring that log back that I've ignored and put this with it. So I'll actually just write it with the square root. It doesn't matter though. So here's my answer for 8. And that's your expanding and condensing. And remember, the condensing is going to be really important because you need that for the solving part possibly. All right, the back. On number 9, we are looping. So one thing that might help is on the left side to have something to loop with. is to put it as an x. And you always start with the base. So I'm going to, on this one, it goes 4 to the x power equals 64. Or 3 to the x power equals 1/9. Or 10, because that's the base that's not there, 10 to the x power equals 1. And on the next set, when I'm looping them, I will have a log written with every problem. And that will be the biggest mistake, is you will forget the log and you're going to loop the exponent back into an exponent. But again, you start with the base. So 3 becomes the little base, 243, and then that equals 5. Or 49 is the base of 7 normal size equals a half. And then 5 of 125th, sorry, equals -2. And that's number 9. All right, the rest of the page, you have to know which formula to use. So if you guys look at the top, you have the first one is just regular exponential growth or decay. You will not see any use of the word compounded in that one. The next one is if you are doing compounded monthly, daily, quarterly, yearly, annually. And then the last one is if you're using continuously, compounded continuously. The final thing that I have up here, this is just for those of you who can't directly type that into your calculator by pressing the math button. You have to use the change of base formula. So that's just a reminder of why that's on there. So I'm actually going to go to number 10. And it says, if a person invested $307 in an account that pays 4% interest compounded annually, so I see the word compounded, I see the word annually, that means I'm going to use the middle formula. I need to find the balance after 5 years. So my job is just to type this in. Now, another thing that I'm only going to point this out up here, well, no, I'll point it out again, is on the blue highlighted one, this fraction, it's kind of hard to put here. When you type that in, you will need to put that in as an extra set of parentheses. So I'm going to start with P, my initial amount, which is 370, and then parentheses, 1 plus my rate, so 4% is a decimal. Compounded annually is 1. Close my parentheses, T is my time, 5 years, and N, it comes again annually. And then you can just type this in. But again, one thing that you will have to do is wrap this in parentheses as you type it in. Type it in exactly as you see it, and at the end, you should have $450 and rounded 16 cents. All right, number 11, a compact car that costs $12,500 new is known to depreciate, so it's going down. Wrong color. At the rate of 15% per year, find the value of the car when it reaches 3 years old. There's no mention of the word compounded, so I'm going to use the first formula, the one that's highlighted in yellow. And to do that, I'm going to take the initial amount of the car, that's the A, and then 1 minus, because it's going down, so I want to use the minus version of the formula. My rate, so 0.15, that's the decimal, and then my exponent, 3. And again, I'll just type that in exactly as I see it. I don't have to worry about any extra parentheses. And when I'm done, I'll get the car is worth $7,676.56. All right, on 12, I'm asking you to tell me where would you earn more money if you invested the $1,370. So in scenario A, you're going to be doing this compounded monthly, which means you're going to be using the middle formula, the one highlighted in blue. And in the other scenario, it says compounded daily. So you're also going to use the same formula, but daily is going to result in a different N amount. So the big difference between these two is here N is 12, and in this one N is 365. So first one, following the formula. The initial amount, 1370, parentheses, 1 plus my rate. It's different here, it's 0.04. My n is 12, and then close my parentheses for 5 years, and then the n comes again. And as you type this into your graphing calculator, you will have to wrap that in parentheses. When you're done, you get $1,672.77. In the next one, I'm still investing the $1,370. I still have 1 plus my rate, but the rate's different. 0.038 is the decimal version of 3.8%. And daily means 365. That's my N. I gotta erase this. And now my time is going to be for 5 years, and then the N comes again at 365. So when you type this into your calculator, don't forget extra parentheses here. When you type this in, you get $1,656.66. So which scenario gives you more money? Situation A. And that is the first learning objective.